Now, the next subtopic from the chapter tree is types of binary trees. Now, what are the different types of binary tree? As we understand all the tree terminologies that are associated with the tree, now it is time to understand what are the different types of binary trees. Now, what are the different types of binary trees? First is the rooted binary tree. Second is full slash strictly binary tree. Third is complete oblique perfect binary tree. Fourth one is almost complete binary tree. Fifth, skewed binary tree. These are all the types of binary trees. Now, this is the diagrammatical representation that explains a different types of binary trees. That is rooted binary tree, then your full oblique strictly binary tree, then complete oblique perfect binary tree, then skewed binary tree, and almost complete binary. Now we try to study all the types of binary tree one by one. First is the rooted binary tree. A rooted binary tree is a binary tree that satisfies following two properties. The first property of rooted binary tree is it has a root node. Each node has at most two children. The first part we have to understand is it has a root node and each node has at most two children. See, I am using at most means maximum two children. If the tree is having beyond two children in a one tree, that is not called as a rooted binary tree. One child or the two child to any node that is to be considered. Beyond that, it is not considered as rooted binary tree. There are two main conditions. First is it has a root node, right? Next is each node has at most two children. So this is important. Each node has at most two children. In figure, the root node A has two children, that is B and C. The node B has at most two children, that is D and E, and C node having at only one children. So it is having the chance of second children also, but as it is having only one children, that is also correct for satisfying the condition of rooted binary tree. Now next is full oblique strictly binary tree. A binary tree in which every node has either 0 or two children is called as full binary tree. A binary tree in which every node has 0 or two children. So every node of the tree should have at least two children is called, or we cannot say that at least, only we say that over here two children, 0 or 2, not at least. 0 or 2 is called as full binary tree. Now in front of you there are two examples of a figure in that it systematically shows that which figure which figure is full binary tree and which figure is not. Now, full binary tree is also called as strictly binary tree. So we have two figure with us. So every node has either 0 or 2 children. So this is very important part over this. So I am underlining this part. So every node has 0 or 2 children. Now see here, if we observe the second figure which is right, in that every node has 2 children. Node A has 2 children B and C. Node B has 2 children D and E. Node E has 2 children F and G. But on the other side, node C has only one children. Right? It is not having 0 children, it is having 1. So it is not a full binary tree. Node B has 2 children, node E has 2 children, node A has 2 children, but it creates a problem when we reach to node C has only one children. So 1 is not required, either 0 or 2. So even number of children are required in the case of full oblique strictly binary tree. Now here first binary tree is not a full binary tree. This is because node C has only one child. So this is the systematic representation of what is full oblique strictly binary tree. Now what is complete oblique perfect binary tree? So a complete binary tree is a binary tree that satisfies following two properties. The first property is every internal node has exactly two children. Exactly two. Every internal node has exactly two children. Now every internal node. Now you go to the slides of tree terminology. Understand first what is internal node, and then you can understand that every internal node has exactly two children. Now all leaf nodes are at same level. All leaf node are at same level. So this is also very important part. All nodes are at same level. Okay, or I'm just rounding this part because this is also very important. And okay, I'm using here pointer. All leaf node are at the same level. All leaf node are at the same level. Leaf node, terminal node doesn't have any child. These are the all leaf node which are at same level. Understand? Exactly two children, which is very important. Complete binary tree is also called as a perfect binary tree. Every node has every node has exactly two children. Okay. Now here first binary tree is not a complete binary tree because node C doesn't have exactly two children. This is only the reason. And in the second figure, every node in the complete binary tree has two children. This is because all leaf nodes are all are not at same level. All leaf nodes are not at same level. Okay, if they are at a same level, then it is a complete oblique perfect binary tree. Now almost complete binary tree almost complete binary tree is a binary tree that satisfies following two properties. To understand every type of a binary tree, we have to first understand what are the properties that they have. So all the levels are completely filled except possibly the last level. The last level must be strictly filled from left to right. Now, what is that? For this, we are considering the figure. In this figure, all the levels are completely filled, hmm, except the last level. Now, see, completely filled means they are having a children, at most two children, and the leaf node are not filled. So, sorry, the except leaf node, except, I'm using a pointer over here. See, all the levels are completely filled. So here our level B is completely filled with the children, at most two children, except possibly last level, which is not filled at all. Now, the last level should be filled from left to right. This is also important, right? So this is the almost complete binary tree. Now here, first binary tree is not almost complete binary tree because the last level is not filled from left to right. Now here the last field is not filled from left to right. Here the last field is completely filled from left to right. Here the last field is not completely packed from left to right. But here the last field is completely packed, completely filled from left to right. Okay. So this is all about the different types of binary tree. Okay. What we have studied, that is root, that is complete binary tree, rooted binary tree, then full or strictly binary tree, and almost complete binary tree. So make a four column in that, write down the definition of each and every binary tree, and try to compare it with the four column so that you can understand each and every concept. Now for the tree, what is the trick? That the trick is only that the part are very descriptive. The part are very descriptive, the parts are very lengthy. The parts are not difficult, but all the parts are very lengthy. Because of that, we feel that it is a difficult. No, as we systematically write down the notes for this chapter as it is required very much, because this is the descriptive part, lots of descriptive part is there or description is there. That's why if you are putting it in a different columns or compare all the time with all tree terminologies or with the all types of trees, you can systematically understand all the types of trees. Thank you.